Yes, class. Am I audible? Sahla, Shaima, Zainab. Zainab, this is your first class. Yesterday you were not present.
No, ma'am.
All right. So see a quick revision of what we have done already so that Zainab, you also understand. We have started with the first unit of your class 11. That is your introduction to physics. We'll not be doing because that is all the forces that are included in your introduction to physics will be discussed later on. Right now, we have started with dimensional analysis. That is a major portion from your first unit. All right, from your entire first unit, you will be getting this dimensional analysis only to be solved. All right. So we had started with the first term that was physical quantities, right? So all those who were present, it's a quick revision for you, or for those who are new today, this will be a new class for you, right? So wherever you're not able to understand, just let me know in between. Zainab, one thing that I had discussed with the students in the last class, that is yesterday we had our first class. So all the notes will be provided in the class. You don't need to rush for the notes anywhere else, right? I'll be just giving you a time so that you can copy it down, whatever part has been taught. Do not write down anything while I am teaching. I'll give you sufficient time to write it down according to your speed only. You can always update me in the chat column. Chat column is always open. And apart from this, if you have any query, if you have any doubts, that also can be answered through the chat column itself. Or you can unmute yourself for answer. After every class, you'll be having after class assessment based upon the topic that we have completed in the class. Like yesterday, the portion was not over completely. So we didn't have, right? Sala and Shaima were there. So what are physical quantities? Quantities that can be measured. And they are classified into two types. You have fundamental quantities and you have derived quantities. So what are fundamental quantities? Fundamental quantities are those quantities that are basic in nature and they cannot be derived with the help of other quantities. And mainly three fundamental quantities are very important in your dimensional analysis part. That is mass, length, and time. These three are very important: mass, length, and time. And then what are derived quantities? Derived quantities are made up by the fundamental quantities. You put up the mathematical operations, the new derived quantity will be formed. All right. So how many fundamental quantities are present and how many supplementary quantities? Sala, do you remember?
Yes, ma'am. There are 7 fundamental physical quantities and 2 supplementary
Very
quantities.
good. 7 fundamental quantities we have and 2 supplementary quantities are present. So we discussed those in detail. These are the 7 fundamental quantities. Mass, length, time are the utmost important quantities out of all these. Then temperature, electric current, luminous intensity, amount of substance. So the portion that has been missed by you, Zainab, what we can do is that either I'll share the link of this with you so that you can copy it down. And please, as I'm emphasizing, these notes are very important because we'll be discussing the theory part here only, the numerical here only, and everything related to your syllabus will be covered. So make the notes well, proper. But for you, if something has been missed, like yesterday's class, so I can share the link with you, or I can share the video lecture, the yesterday's class video lecture with you. So at least you can go through the video lecture, you can forward, increase the speed so that you get the gist. So these were the things only which we discussed. Again, I'm telling mass, length, and time are most important. Then Kelvin, this temperature and current. This will also be used sometimes in the question, temperature or current. Luminous intensity and amount of substance are least used in your numericals. The 2 supplementary quantities were plane angle and solid angle. Plane angle, the angle that we draw in our notebooks only. The intersection of 2 lines, that is known as the plane angle. And what is meant by a solid angle? A solid angle is an angle that is formed in 3 dimensions, that is 3D. So how is solid angle formed? Like if the best example, if you take the example of a cone, if we take a piece of paper, we draw it in the form of cone, we get a 3D cone inside it. That is the 3-dimensional angle, right? So that is known as solid angle. So plane angle has the unit radian with the symbol theta, and solid angle has the unit steradian with the symbol omega. Solid angle is usually not used. That's why we are also not familiar with that. But you should be aware because this is a part of your syllabus and anything can be asked in the exam. Then derived quantities we'll be slowly see. Now come to the main part, dimensional formula, which I want you all to know it properly, because dimensional formula, this is such a part that I mentioned in the last class also, that some portions of it can be asked even in your entrances, in your JEE exam, your NEET exam, your after class 12th entrances, college exam. So this is a very easy portion, very scoring portion, and the easiest portion of class 11. Do not judge class 11 by this lesson. The next concepts that we'll be studying in the upcoming lessons, those will be having a little more weightage than this. The concepts are also difficult over there to understand. Conceptual portion is there, but you will be able to manage it if you revise it thoroughly. One thing that I was telling here, dimensional formula is the easiest part. So just practice it daily. All right, before we start, before we complete it, so that you will also have a proper idea how to find out dimensional formula of anything. Right now, formula you do not remember, right? But as we'll be going through all the chapters, you will become familiar with the formula. Anything if you want to ask class, you can keep on asking in between. All right, in between the class also you can ask. So how do we write the dimensional formula? I told you three things are present: mass, length, and time. The mass, length, and time, these are expressed with the help of the actual formula. Like area. What is the actual formula of area? Length into breadth. How do we write length? L out of the fundamental. We have to form the dimensional formula using the 7 fundamental quantities that we have. Understood? Length, so L. Breadth is also a length out of all the seven fundamental quantities that I've mentioned. Length is related to your breadth. So the formula became L square. Since mass is absent, time is absent, we can write it as M0 L square T0. All right. Similarly, we had seen the formula of volume. Volume is length into breadth into height. So length can be written as L, breadth can be written as L, and height also can be written as L. So the formula became L cube. So here this can be written as M to the power 0, L to the power 3, T to the power 0. First, tell me class. This was a revision of the entire yesterday's class. Since these are the initial days, that's why I'm going a little slow. Tell me all of you, this part is clear? Anything that you want me to repeat? Any part that you wish to be repeated in the class? Any query? Or should I go forward? Zainab, this is fine till here?
Yes, ma'am.
I'll share the video lecture also so that you also can see the entire video. Sahla, Shaima, fine by both of you?
Yes, ma'am. Thank you.
Yes, ma'am. All right, perfect. Let's see some more examples based on this. One example, let us see, then we can take a break and then see how to find out the rest. See, density. The formula of density is basically, see, density is represented by the symbol rho. You will be studying density a lot in your chemistry, in your class 11th, in your class 12th. Density will always be there. Not even in just chemistry, in your physics, in your chemistry, it's there, in your bio also, density will be present. What is density? Density is mass by volume. All right. How do we write mass in terms of all the fundamental quantities? We already have mass, right? How is mass written? M. Volume. How is volume written? We have already calculated how is volume written. Length into breadth into height. That is L cube. See, if this is, so when this L will go up, this will become, this is already 1. This will become -3. Right? Here it is in the denominator, but when it will go in the numerator, that will become -3 because the powers sign gets reciprocated, right? So what is the formula? Either we can write like this, M1 L to the power -3, or M1 L to the power minus 3, T to the power 0 because time is not present. Like this. This is how we write the dimensional formula. We'll see some more quantities, distance and velocity, all the formulas that will be coming. Right now, I will tell you the formula because you all do not. We have not done all the lessons. But by the end, when you will get your final exam paper, at that time, all the questions will be mixed up. Any formula can be asked because you have already done it in your throughout the year. So, but right now, I'll be giving you the formula. And right now in your in text and back exercises also, formulas will be mentioned. So do not worry about the formula, that how will you get the formula. Write it down, write this portion. Zainab, you can leave 2 to 3 pages. Then you can start with this. Then you can complete it. We'll start with it. Write it down and the chat column, once written, just update me, done. Now, again, as I've discussed, some formulas I'll be telling you. The purpose here is not to remember the formula. Do not remember the formula right now. You will remember the formula directly when we'll be doing all those lessons. All right. So do not remember the formula right now. Right now, just focus on how will you be solving and how will you be getting that dimension. Our purpose is to find out the dimensional formula. So right now, we'll be focusing on how to form the dimension formula like this. Easy question. It's a very easy lesson. So though it's a very big transition from a class 10th to 11th, but this chapter will not scare you much. All right, you will have confidence in this lesson if you keep on practicing it. See, the first quantity that we get here, this is distance. Distance or displacement. Distance or displacement, there's a difference between them. Distance is actually the total path that we measure, and displacement is the shortest part that we measure. This we'll be studying in the kinematics portion. So distance is just length. So what is the formula of distance? It's just length. So dimensional formula will become L, nothing else. SI unit is meters, CGS unit is centimeters. Easy. Coming to velocity. Velocity, you must have studied in your 9th class also. Velocity, kinematics, all these terms were there. So velocity or speed. When we say distance by time, that becomes speed. When we say displacement by time, that is velocity. But if this is the formula given, how will we construct a dimensional formula? That is the task. How do we write distance? We write distance as L because that is the length. You have to choose out of all those 7 fundamental quantities and write it in terms of that. And time, we already have the formula for time. We already have the fundamental quantity as T. So when this T will go up, this will become T to the power -1 and mass is already 0. So this way you can write, or you can write M0 L to the power 1 T to the power minus. Clear? Distance is SI unit is meter, times SI unit is seconds. In the last class, yesterday, we have done this. So this becomes meter per second. And in CGS, it will become centimeter per second. First, tell me, is it clear till here? Yes?
Yes.
All right, good. Two more terms I'll tell you, then you all will be telling me. All right, that's why I'm saying wherever you are not understanding, just let me know in between. Acceleration, there's a term acceleration, that is velocity by time. I'm not going into the details of these because these have their separate chapters, so otherwise time will be wasted. So I'm just focusing on how to form the dimensional formula. If anyone wants specifically to know what is that quantity, what is that physical quantity, you can tell me. I'll just give you a brief. Yes, velocity. What is the dimensional formula of velocity? We have calculated. It's L to the power 1, T to the power -1, right? In the previous part, we have calculated. And what about time? Time is T to the power 1, right? So when this time will go up, see what will it become? L to the power 1 is there. T to the power -1. And this one will also become -1. So what do we have? We have L to the power 1, T to the power -2. Or you can write this as M0, L to the power 1, T to the power -2. And this was meter per second. One more second came, so meter per second squared. Or centimeter per second squared. This is acceleration. One more quantity, momentum. Till momentum only I'll discuss. Formula of momentum, let me tell you. Momentum's formula is basically mass multiplied to velocity. Fine. Let's form the dimensional formula. Dimensional formula formation questions will be coming in the exam. That's what I'm saying. What is mass? Mass is m. Multiplied to velocity. What was velocity? L to the power 1, T to the power -1. So when you multiply these, this will become m, L to the power 1, T to the power -1. Clear? What is the SI unit of mass? Kg. And what is the SI unit of velocity? Meter per second. So both got multiplied. What about the CGS? Gram per centimeter second. Sorry, gram centimeter per second square. This will become gram centimeter per second, the CGS unit. Clear? How have we written all these formula? Now, till these portions, these 7 quantities which we are writing, then I'll give a break. We'll practice some numericals. Then we'll come again back to the list. But see, at least these 7 quantities which we'll be doing right now, these should be learned by all of you. All right, you should learn all of these. Reason is that these will be used somewhere. Like in the calculation of acceleration, we used velocity. So if you remember the formula of velocity, you can directly write it. We'll discuss that later. First, make this table in your notebook. Start making this table. Start writing it down. Serial number, physical quantity, CGS unit, dimensional formula, SI and all. Those who have completed in the chat column, tell what will be the dimensional formula for this force. Force's formula is mass into acceleration. Acceleration you have calculated here. Tell what should be the final answer. Yes, very good, Shaima. This is mass into acceleration. Mass is m, right? Acceleration is L, t to the power minus 2. So when these will be multiplied, it will become m, L, t to the power minus 2. Correct. Shaima has answered this. See, SI unit of force is Newton and the CGS unit of force is dyne. If you will complete, just tell me for work done. Force into displacement. Others also answer in the chat column. Am I audible now? Just check.
Yes, ma'am.
Screen sharing is paused. Let me check. Now it's fine. My voice is coming. Screen is sharing.
Yes, ma'am.
All right. Yes, all those who have answered. Sela says ml to the power 2, t to the power minus 2. And Zainab ml t to the l to the power minus 2 into l to the power minus 1. See, Zainab, you have to multiply them and then tell the final answer. Like we have multiplied this. This is the final dimensional form. And this is Shaima says ml to the power 2, t to the power minus 2. Correct. Right. All of you right. Zainab is just that you multiply the formula, you'll get the same thing. We have work done. Work done is force into displacement. What is force? Force is this. And displacement is multiplied to n. Right? So when you will multiply, L into L will become L square. So M, L to the power 2, T to the power minus 2. The SI unit is joules and the CGS unit is erg. One more I'll tell. Let me discuss, then you can write down all these together. Pressure. Pressure is force upon area. So force again M, L to the power T to the power minus 2, L to the power 1, T to the power minus 2. And then we have the area. Area again we have discussed, length into breadth. So this becomes L squared. That means 1L and 1L will be cancelled. Or if this L goes up, this is already having 1. This becomes minus 2. So 1 minus 2 will become minus 1. T to the power minus 2. Pressure's SI unit is Newton per meter square and the CGS unit is dyne per centimeter square. Now, one thing, this is important, work done. All the energies that you will be getting, all the energies formed, like kinetic energy, potential energy, any sort of energy, work done, anything related to energy. This is the trick to remember. All of them will be having the same dimensional formula. Whether it's your kinetic energy, whether it's your potential energy, any energy, it's present, any sort of energy. So work done and types of energies have same dimensional formula, that is M L to the power 2, T to the power minus 2. See, we have lots of physical quantities, we have lots of dimensional formula, and it's very difficult for you to remember all the dimensional formula. So what you do, at least, not even pressure also you'll be able to write. These 6, or even if you exclude momentum, distance, speed, acceleration, force, and work done. These should be on your tips. These 5 should be on your tips. You should learn the dimension. Because as you will be seeing the question, you will notice that these formulas will be having their direct application over there. Understood? So it will be difficult. If suppose I ask you momentum, that's mass into velocity. If you do not remember velocity, you will first write down it as distance upon time, then you will calculate that, then multiply with mass. If you remember directly, you will multiply these two. Okay, so that's why I'm saying at least these 5. These are some things that are important for your preparation part as well. Right now you have a very less syllabus, but at the end I have told you yesterday also, 11th standard syllabus is very vast. All right, write down till here, then we'll see a question, how actual questions will be there in your exam. If you have completed, let us discuss this question so that you'll also have an idea how to practice all the questions. See, F is the force, G is universal gravitational constant. Again, I'm telling you, your purpose is to write the dimensional formula. This you have a full lesson. Chapter 8 is there, that is based on your gravitation. So there we'll be doing it. M1 is the mass, M2 is the mass. R square is what? R square is basically the separation. That is the radius. Now we have to find out the gravitational formula, sorry, dimensional formula for capital G. So see, F is equal to, in this, F is equal to G M1 M2 by R square. So from here, capital G will be equal to F into R square divided by M1 into M2. Now what we do, we put all the dimensional formula. Force we have calculated, its mass into acceleration. So mlt to the power minus 2. Square of radius. Radius is length. So square of radius will become L square, right? M1 mass will be M. M2 mass will be M. See, 1M will be cancelled. So this will become M to the power minus 1 when this M will go up in the numerator. L into L square. This will become L cube. And what is time? Time is T to the power minus 2. So this is the formula for universal gravitation constant. Write it down. One more question we'll practice. I hope you've written the question. If not, just let me know. I'll scroll up.
Ma'am, could you please scroll up for 1 second?
See, F is equal to G M1 into M2 by R square. Now we have to find out the dimensions of capital G. So if we want to find out G, G will be equal to force multiplied to R square, right? And then these two terms will go in the denominator. So capital G will be equal to F into R square by M1 into M2. Till here it is clear to all of you?
Yes, ma'am.
All right. Now see, when we put it in the formula, what is force? Force is mLt to the power minus 2. What is the radius? For radius, we write it as L. So radius square will become L square. So this is L square. Mass 1, M. Mass 2, M. Fine. Now see the calculation part. M is there in the numerator, M is there in the denominator. And one more M is there. 3M. So 1M will be cancelled. What is left? M to the power 1 is left here. Only this one because these two have been cancelled. So when this will go up in the numerator, this will become M to the power minus 1. That's what we have here, M to the power minus 1. Come to length. One length is L. Second length is L square. L into L square will become L cube. That's what we have. And about time, what is the time? It's L T to the power minus 2. So only T to the power minus 2 because nothing else is here. So this is the formula. Now it's clear, or anyone wants me to repeat again? I'll repeat it if you have any doubts. Clear? Yes, no, what class?
Yes, ma'am.
Yes, ma'am.
Yeah. See, coming to this, f is equal to eta a dv over dx. So when we are talking about eta, this is the coefficient of viscosity. We'll be studying this. This is area, this is change in velocity, this is the thickness. We have to find out the dimensions of eta. See, what is the formula? Formula f is equal to eta a dv over dx. So if we write out what is eta, this symbol, this is force multiplied to distance divided by this area into velocity will come here. Now see, let us write down the formula of everything. What is force? Force is mass into acceleration. This is the formula for force. What is thickness? How will we write the dimension for thickness according to you all from all the fundamental quantities that we had? Yes, what do you think, class? According to you, for thickness, what should I write? Yes, Sala.
Mass?
No, thickness, something. How do you measure thickness? Then related?
Length.
Length, correct. Always try to recall how do you measure it. So thickness is actually length only. So L will come. Area is L square. Velocity is L t to the power minus. Now check the calculations carefully. Length, we have mass, only 1 m is there. So m to the power 1. Length, L to the power 1. And this 2 will become minus 2. So 1 minus 2 will become minus 1. Clear? 1L got cancelled. L to the power 1 divided by L to the power 2. So when this will go up, this will become L to the power minus 1. Similarly, t to the power minus 2 is there. And this minus 1 will become plus 1. So again, this minus 2 plus 1 or 1 minus 2 is minus. So these are the dimensions of coefficient of viscosity. Clear? Write down the solution. All right, so I'll stop here today so that at least you can appear for your after class assessment. Just log into your portal, log into your Learnivio account in your Learnivio app. Just contact the management for the support also if you have any query. Attempt it. Revise till here. Next Saturday, I think we'll be having the class now on Saturday only. So we'll continue from here. Some more quantities are left. This table we'll complete now. All right. Thank you so much, class.